Software testers do not make software, they only make them better. This anonymous quote on software testing stresses the importance of software testing in our field. This is why we have a special resource person for our ICT guest lectures series today. Hello everyone, I am Ravi Fugwa, lecturer at the University of Technology Mauritius, and I am pleased to be your host for this online ICT guest lecture series. Some ground rules for this event. Please remain muted until the end when you will have the opportunity to ask questions. Please aware that this event is being recorded and the recording will be shared with you after the event. Our resource person today is from the Mauritius Software Testing Qualifications Board. The MSTQB is a non-profit organization whose mission is to promote software testing, knowledge and profession across Mauritius. MSTQB is the local member board for International Software Testing Qualification Board, ISTQB. It is responsible for promoting the certifications to the Mauritian population. All the members of the MSTQB are volunteers. As for our resource person today, while we are honored to have among us the founder and the current president of the MSTQB, he's a software testing coach, a conference speaker, and ISTQB trainer. Please join me in giving a warm welcome to Mr. Lovelesh Beeharry.
Thank you, Mr. Ravi. Thank you for the introduction as well. If you allow me to introduce myself, I am Lovelesh Beeharry. So I'm a QA consultant. I'm a training coach as well in software testing. I'm also the CEO of a company over here in Mauritius for the administration of examinations and so on for software testing. I have around 11 years of experience in software testing on the Mauritian market. During my professional career, I've been working for more than 5 companies here, multinational companies. My core competency resides in manual testing, automation testing, and performance testing. So we'll talk about these as well today in our speech, in our interaction. We'll have the chance as well to just dive into about automation, performance testing, and manual testing. And as Mr. Ravi mentioned, I'm the current president of MSTQB, which is the Mauritian chapter for ICTQB, International Software Testing Qualification Board. And I also carry out some conferences. I'm a conference speaker, both at the national and international level. That's a bit about me. Now let's dive into our interesting topic for today, which will be about software testing and quality assurance. So this field actually is very vaguely understood by the market, I would say, especially in Mauritius. So this is why I chose this topic to actually reveal the hidden world of software testing to everyone out there, and to be able to for them as well to know a bit about this field, and also this may help as well on the long term to channel few of you towards this amazing field under IT. So when I talk about software testing, the first image that I actually try to convey to the audience is about tea making. So when we are making tea, there is always this inconvenience of having the tea leaves into the cup, and then the consumer of the tea will be drinking those leaves, which goes a bit of I would say not a convenient or the best experience of the tea. So what do we do then is actually we use a strainer, or a tea filter through which we will filter the tea, and then we'll have a refined product, which is the tea at the end, and we can enjoy it with its full taste and so on, without having the inconvenience of having leaves in it, or spices, or whatever be ingredients that you add to your tea in the tea at the end that could actually hamper the experience. So software testing follows a similar analogy with it. As software testers, we are actually the sprainer. We are the one who are removing those defects from the software. Therefore, software quality assurance, which is the umbrella under which software testing resides, it's all about delivering real value to the end user, just like having a good experience with a tea after that have been filtered through the strainer. That's about software quality assurance in terms of delivering the value to the end user. So the end user may be internal clients for a company, like developing a software for its internal user, or the public in general. For example, we have operating system like Microsoft, Windows, we have Office 365, and so on. So those are products, and software testers and the quality assurance process actually ensures that these software are working well and providing real value to the end users. In this case, the end users are the public in general. And software quality assurance, the process when implementing the process as a software tester as well. So we are dealing with risk on a daily basis. So software testing is highly, I would say, highly proportional to risks. So we deal with risk on a daily basis. So the risk can be in terms of a product or in terms of project. So product risk would be something that is not working well on the product, and project risk will be something like we are not able to meet the deadline of delivering the product to the market, or we don't have enough resource to work on the project, and so on. So those risks forms the day-to-day things that we handle on a software testing project. We also, as software testers and as part of the quality assurance process, we also have to devise certain right techniques to be efficient in our test, because you will see it in the subsequent slide that we are not able to test everything. So we have to apply the right technique, the right test technique to be efficient in what we do. And that's also part of our day-to-day work as a software tester. So quality assurance as a whole, if you see it, it's a chain of activities that starts from analysis up to the release of the product. So analysis of requirements, analysis of user stories, then we have impact, trying to get the impact, and then we have the test conditions over which we'll write test cases, then we'll have the execution part, then we'll have the reporting, and then after all the risks are dealt with, we'll have release to the market. So those chain of activities actually termed as the quality assurance process, under which there is software testing. So through quality assurance process, we are able to protect the brand power of software and the software name, the company name as well. So if we have giants today in the IT world, like Microsoft, like Apple, we as software testers heavily contribute on protecting those brand name, making sure that the product that they deliver is of quality, and therefore we still remain as a reliable product on the market, which actually attracts others as well to be customer of those products. So that's as well one responsibility as software tester and quality assurance. Right. So I would like to use this opportunity for conferencing as well to just clear some few misconceptions that I've heard on the market and my interaction with few students, few professionals as well on the market, that testing is easier than development. Well, it's not easier. It's two different skill sets that are required. As a tester, we have a quality mindset. As a software tester, software test engineer, those are the same word. We have multiple job title that resides on the software testing. For example, we have software test analyst, we have tester, we have software test engineer, we have software quality assurance engineer. Those are I would term as quality engineer or software test engineers. So there is a misconception that software testing is easier than development. So anyone specialized in software testing will have a quality mindset rather than a technical mindset. A technical mindset is for the developer, and what is actually the misconception here is that testing is easier. So when we say that the skill sets are different, the job responsibilities as well, and the day-to-day job as well are different. So in this case, when I say that we have a quality mindset, what I mean by that is we have to think outside the box as a tester to find certain scenarios, certain flow in the software where bug may reside, and we have to apply the right technique. So the work is technical as well, but it's not the same skill set as development. It's part of the skill set on top of the quality mindset that we need to have. It's imperative to have this quality mindset. The second misconception is that software test engineer or those job profile are low paid job profiles. So given that the skill set are different, but the value that we create as software test engineer, and it's the value that we create for the company and for the market, we have a greater impact on the value, on the end product value. So this is a misconception. Normally, a software test engineer and a software engineer or a developer will fall in within the same grid because it's a different mindset, different job responsibility, and different value as well that we are creating for the market. Testing is only about executing the software to see if it works. That's a heavy misconception over here because uh, it is often perceived that as a software test engineer, we are just executing the software just to find bugs. But the job doesn't start over there. It starts with the analysis phase where we have to first read the user story, understand it, design certain test cases, find the impact, investigate the root cause, and so on. So testing is not only about execution. There is a chain of activities which falls under quality assurance, which actually guides how testing happens. So when you hear that testing is something just about executing the software just to find bugs or defects, so this is completely wrong. It's not. It's part of it. It's not the whole picture. And also, it is also perceived that the testing acts as a bottleneck in the software development lifecycle. Why it's perceived this way? It's because we have back and forth. Sometimes we have back and forth between testing and development. We find bugs, we find defects, and we have to send it back to development, and they have to fix it. We have to test it again. We have to do different levels of tests. One of which is system level testing. We do actually have quality gates in the SDLC, in the software development lifecycle, and these quality gates are actually creating value, creating quality, which will be very much useful for the company at the end of the life cycle, and also for the end user. So it's not a bottleneck, it's only a value creation process. And also there is some criticism that testing is all about finding um, miss or defects or bugs in the developers. So it's perceived that testing is only about criticizing the work of the developers, which is incorrect as well, because as testers we need to have some soft skills as well to report bugs. The aim behind is to provide risk to enable stakeholders to make informed decisions. So by doing so, we have to be fact driven. So we don't have the bias. We need to control the bias, the confirmation bias, which is about um, reluctance to agree to a certain point when it is concerning your work. So we have to be above that. That's first. And then as well, we have to ensure that we are creating value for the company and for the end user. And by doing so, we need to find defects and we are embellishing the product. In the agile mindset now, quality is not only the responsibility of quality engineer or test engineer, it's a responsibility of everyone. That's the agile mindset. We don't have, in agile, we don't have development team, we don't have QA team, it's scrum team. So everyone actually in the team is working towards quality. We on as testers on the scrum team, we are doing extended testing to ensure that the product is actually abiding to a higher standard of quality. So it's not about criticizing the work of developers, it's working together with them to create something of higher quality. Testing doesn't require much technical knowledge, which is wrong, which is totally wrong, because we have technical fields in testing. For example, we have performance testing, we have automation testing. Those require technical knowledge. Those require as well a deep understanding of mathematics in performance testing, especially. So we have to understand the concept of the spread of data, the standard deviation variance. In performance testing, we use the concept of calculus quite often. So it's quite technical, it's quite scientific in approach. So testing in itself does require some technical knowledge, especially when you're doing automation as well. You have to write automation framework, you have to write scripts and so on. So you need some kind of um, of coding knowledge as well to be able to deliver automation script, performance script. One cannot make a successful career in testing, which is wrong, because I've been in the industry again for 11 years, and I have progressed in that industry, in the quality industry, for my whole career now. And I've grown through different job position. I started like an associate software test analyst, and I grew to a test analyst, then to a software test engineer, then to um, an automation engineer, performance engineer, then to a lead of a team, and so on. So there is a full-fledged career in the field of testing, in the field of software testing. So this is also a heavy misconception here. And the last one is there is no innovation evolution in the field of software testing. I've heard that as well quite often, because of the first one, of the first misconception, that it is easier. So there is a misconception that there is no innovation in evolution. So I have a slide on that as well. I'll show you how actually testing evolved through time, how automation grew, how AI is now being used in testing, and those are all chains of evolution, and how actually as well now we are speaking on testing on the cloud, testing on blockchain technology, and so on. So those are innovation that is impacting directly the field of testing. And so it's full of innovation, and there is a lot of knowledge out there to be gathered. So those were a few misconceptions on software testing. And what happened if actually some organization they neglect testing? I have one famous incident that happened with Microsoft, and this event that happened over here is the famous BSOD, which is the blue screen of death. They were doing a demo with the whole world. Actually, every media was there, every um, um, reviewer for technology were there on the event, and they were showcasing how Windows 98 is better over its predecessor Windows 95, and they were trying. Microsoft there was trying to get the bigger market share, because in few weeks time, down after this event, in few weeks time, Apple was about to release its new operating system for Macintosh. So they were trying to be the first move over there, and they neglected a bit of testing. So in this video, you will see that there is Bill Gates and the chief engineer over there, who is trying to showcase that they're trying to plug a scanner, and they get a blue screen of death, and it's live in front of all the media and the whole world, actually, basically, and it's broadcasted on CNN as well. So there is a moment of discomfort you will see on Bill Gates face, and the chief engineer as well. They're trying to blend in some conversation just to let the time pass and let the system reboot. So this happened actually because there were time pressure and testing was neglected. So they didn't test with the scanner. They didn't do full-fledged testing on those modules. The aim was just to release it to the market and sign as much as contract as possible after the event to get the greater market share on the of the industry with Microsoft, because there was time pressure, because Apple was going to launch their product as well a few weeks down the line. And the consequence was just the opposite, because they had this issue. The trust on the confidence on the Windows 98 operating system fell on the market, and Microsoft took a hit on that, and they had to reconsider the way Windows 98 was designed, and they had to release Windows 98 SE, which is the second edition, and that Windows, actually, that operating system picked up on the market. But by then, Apple, who did the testing, who did the full-fledged testing and so on, didn't compromise with quality. They were able to get a good share on the market, and they are still rival today as well. So that was the hard way for Microsoft to learn to actually learn on the value of testing as well, and manage their business expectation, their the pressure for the company to be the first in the fields and so on, and by not compromising quality. So this is one example. There is another one, which is which happened recently with Tesla. So you might be knowing Tesla for the car, the EV, the electric vehicle. So when Tesla was selling a lot of his electric vehicle, the car one, so they wanted to venture out in another market, which is the Cybertruck. And again, they were confident about their product. They were confident about the product, and um, they move forward with showcasing the product to the public, to again have the first move advantage, to show that the company is growing massively, is investing in different products, and is doing a lot of research and so on, and they are here to be the market leader. So in this case, it's not a failure of software, but it's a failure in terms of a hardware. I'll just show you the interesting part. So this is about how spacious the car is, and they wanted to test as well the how strong the vehicle is. So they try to hit the car with a hammer just before they hit it with a normal door for a car. You'll see it here. There is a dent that is there, and they try to do the same on the Cybertruck, and it withstand the blow, right? There is no dent. So that was one. The second thing that I wanted to showcase was the glass, how the glass was strong. So they did a test on a normal glass, and it shattered, right? And this is the Tesla glass now. They released the ball um, from a higher location, and it didn't shatter. And they asked someone actually to throw the ball of steel now to the Cybertruck. And when they do it, uh, it shatters. So this is actually things that we have to deal with as a software tester or software test engineer on a day-to-day basis. So this is what I will term as the parameter of testing. When they did the test, when they showcase it on the glass by throwing the ball vertically down, it didn't shatter because it was perpendicular. But when someone will actually attack the vehicle or will throw something at the vehicle, it will do a parabola, and that whole make a difference actually in the way that it was tested. And that you can see again the disappointment and the uncomfortable position in which Elon Musk is, and he had as well to bridge, to stop, to cut off the the demo of the product earlier than actually expected. So as you will have guessed, Cybertruck didn't pick up quite much on the market. There were quite some units sold, but they didn't hit the market target that they wanted to reach. So those happened because the quality aspect of the product was somehow compromised just to be the first leader, or because of time pressure, or they just wanted to showcase the versatility of the project of the company, how diverse the product that the company is creating on the market. So by doing so, they compromise quality, and down the line they had to incur some loss as well. So all this to tell you that the quality of that we are talking about, the software quality, is not only about how the software is functioning. Okay, so when the software or the system that we are testing is functioning well, we are making sure that it's abiding to the requirement, the initial functional requirement that is set. For example, when you have WhatsApp, you should be able to send messages, images, GIF, emojis, smileys, and so on. So those are functional aspect. And when we are testing it, with these requirements in mind, we are doing functional testing. What does the software do, and what should it be doing? So those would be functional tests. But if we do functional testing and we say, okay, we are ready to release the market, we are missing all the other aspect of testing. And this is the hidden world of software testing. And those parts are actually known as non-functional testing. And it's very important as well for these tests to be done. And this is my specialization in the world of testing. So in the non-functional test, we have load testing, which is about increasing the number of users connected to the system progressively to find the snap point where actually the software crashes. So that we know how many users can the software concurrently handle. For example, if we have Facebook, so we have millions of users connected to Facebook concurrently. You may be connected right now as well on a tab on Facebook, and I'm connected as well on my mobile on Facebook. So we are using Facebook concurrently, and there is a limit to which, because it's finally it's hardware based. So there is a limit in terms of memory, in terms of CPU cycle, of how many users the server can handle. And if we are selling a software, we're creating a software that is not abiding to these multi-user environment, then it is supposed to abide to multi-user, but it's not. Then the quality of the software and the value that will create on the market will be very limited. It will be very volatile. So it's only for few period of time that you will actually create a value, and then once your customer base grows, you will find yourself in difficulty to maintain the same quality. So this is load testing, and stress testing is um, adding a certain parameter of test. Like let's say a user is supposed to be using a software for on average like 2 hours per day, something like that, right? And as a non-functional tester, when you're doing stress testing, what you will try to simulate is the same user trying to use it, multiple users trying to use it for 8 hours or 16 hours continuously. So that's adding a stress on the software, and you're making sure that the software is still performing well after these um, uh, elongated time are actually injected onto the system. So this is one way of stress testing. Another way would be you add just a surge of load of users in a short lapse of time. And this is something practical in life, in day-to-day life as well. Um, we had a similar situation with Amazon when they launched their product. The first e-commerce platform was launched, and they had Black Friday um, promotions on there. They wanted to just have a surge of client to buy their products online and make a lot of money out of this, but they didn't do stress testing. And during that, the expected person that they were actually trying to get exceeded. It was more than that, and their whole platform went down. And for each minute that the platform went down, they made huge losses. It was counted as millions of dollars of loss per hour each hour that their system was down. So this is about stress testing, adding a huge amount of user in a short lapse of time and still checking whether the system is still working. And volume is something different. Like we have we keep a certain number of users constant on the platform, but we are increasing the size of the database. So initially when we test, let's say we are testing the software with 20 users with 1 GB of database connected, and then we just disconnect the 1 GB and plug the 10 GB, and we see how the software behave, what's the change in terms of response time and so on. So this is volume testing. Collectively, load, stress, and volume, they are collectively known as performance testing. So those three would fall under the umbrella of performance testing. And now with the evolving law, we have conformance testing. We have GDPR, which is now very much an obligation for any software who would like to operate on the European market, on the US market. So GDPR would be um, the conformity would be the law that actually need to be applied to. So how you will ensure that your software before release is conformance to these laws. So it will be in conformance testing. You will go through auditing of the software, making sure that all the guidelines, all the checklist of the law has been fulfilled, and so on. So this is conformance testing, still non-functional. It's a non-functional test. Then we have compatibility testing, making sure that a software application, if it is deployed, let's say um, as a web app, okay, let's say Facebook itself, why not? So Facebook, it should be compatible with Edge, with Chrome, with different browsers, Opera, even on mobile as well, on browsers on mobile and on app. So making sure that the software is able to operate on different platform is compatibility testing. So we are making sure that it's cross browser and it's cross platform. Portability testing. So we have different architecture in terms of a system itself. We have 64-bit. Now all the machines that is coming out now is 64-bit machine, but we also had 32-bit machines in the past. And we have ARM processors where the architecture is different. ARM processors are mostly used in mobiles and so on with Android system, and we have the iOS architecture. So making sure that software from one application from one platform can run onto the other without modifying the software itself is portability testing. So some software actually come in portable version. It means that you can just have the archive or the executable file, just execute it over there and it will run. And you can just copy the same archive and put it in another platform, different architecture, double click on it, it should run. Right, that's portability testing. Then we have usability testing, which is the ease of use. How easy is the software to use? If a software is providing a lot of features, but it's not easy to use, that will still cut down your customer base. So usability is very important as well. Then we have accessibility. If you're making a website which is open to public, right? Let's say over here in Mauritius, we have the government website or mighty.mu. Those websites are tested to make sure that anyone in the public would not have difficulty to actually use those websites. And how they do it, they make sure that there is enough contrast between the words and the background. The images are people are able to actually find differences in the images so that even a colorblind user would be able to use the application. So this is accessibility testing, making sure that the system is compliant to the use by anyone in the general public. Then we have security testing, very important one. Security testing, making sure that the system is protected in some way so that hackers cannot misuse the data that is connected. Down the line, this is also for some industry, it is also a legal requirement to do security testing. For example, if you're dealing in payroll, so your payroll information, the organization for which you're working will hold quite some PII information, which is personal identifiable information, PII information. My credit card number is a PII information. My ID card number is a PII information. Even my email address is a PII information. So by security testing, you would ensure that those information are protected. They are not liable to hackers for them to be able to get access or to misuse those information. So in these kind of tests, you would do SQL injection. You will try to simulate the man in the attack, man the middle attack. Try to simulate that scenario on the system and making sure that those attacks are actually handled by the system and the data is not publicly made available. Then we have resiliency testing, which is about taking one, let's say we have multiple servers connected, which is providing a software. Okay, and all the servers are actually having load balancers and so on behind in the architecture. In resiliency testing, I would try just to take one server down and make sure that the experience of the user over there is not heavily impacted. They are still able to use the system, even though one server is down. So this is something that is quite often tested on the cloud as well. When there is one site, one data center, which is off or offline or down. So they would make sure that there is another data center in a different region that is able to take the load of the users there. And this is something as well that I've noticed in the morning when I'm trying to access one of my mailbox, Yahoo. We have some issues as of now to access Yahoo mailbox. I believe one data center is down, and the traffic is not being redirected, or it's already saturated on the different data center which is taking the load. So if you try to access yahoo.com right now, I just tried it before this meeting as well, before this conference, and it was still down. So this is something that happened today. This is about resiliency testing. All these, apart from functional testing, all the other type of testing falls under the umbrella of non-functional tests. And it's not only limited to these, there are much more than that, but I don't have enough space to include more. So non-functional test, I would say, is the hidden part of the iceberg that we see on testing. Right. So now let's dive into some key event in the software testing field across history. So in 1947, there was Amiral Dr. Grace Hopper, who actually who reported the first bug. And the bug at that time was actually physical insects. So that was a moth that was actually on the chip. So back then, the industry was more hardware oriented. So it was programming on the hardware. There was the concept of software was very limited. So it was mechanical machines and so on. And Amiral Grace Hopper was a computer scientist in the army. So she was actually trying to get a program working, a system working for the army, and they were getting the wrong result each time because there was a moth that was sitting on the chip. So the moth, also known as a bug, so the act of removing that bug from that moth from the microchip was known as debugging. So this is where actually the concept of bugs come. It's the act, and the word debugging was first used back then. So the act of removing that insect from the chip was debugging. So this was the first bug that was reported in history. And then after that, when we had the boom in software, when giants like Microsoft, Apple, IBM, and so on, they started industrializing the IT, making computers a business machine. So this is where a company actually found value in setting up a QA team, in setting up software testers, professionals in the team, and they started industrializing it. This is where we gain in terms of maturity and how testing should be done, what techniques should be applied, and so on. Then there was a shift in the mindset in the industry when there was, in 2001, there was the Agile Manifesto that was created. So it was a bunch of software developers that came together with a testing team, and they started collaborating together on finding ways of improving the value that we are delivering to the client. So there were 4 values that they created and 12 principles. The basic one are actually collaboration and interaction within a team member rather than having to follow the process and the tools and so on. So this actually shift in the mindset, they impacted this shift in the mindset impacted the way testing was carried out and the way the testing team was seen by the market as well, because testing now with the agile mindset is an integral part of the team. And also there was quite some importance given to early testing. So what I mean by early testing is to start testing. There is a misconception again that testing happens only after coding. It's only when we get the code that we can start testing, which is completely wrong. We can start testing as the requirements are finalized. So we have static testing where we are finding defects in requirements, defects in work product like source code with user stories, with architecture diagram, database design, so on. So this is where testers actually do static testing, and once the code is written, the software is written as well, they would do dynamic testing, which is execution of the software to find defects. So this shift in mindset happened in within the agile manifesto when it was created, when it was drafted by those developers and testers. Then we had the rise in automation testing. there was a concept of why should we be doing manual testing when we can program a computer to do the same test again and again um, down the line in loop actually. So there was the rise in automation testing. Then there was the formalization of non-functional testing in these years, in the years um, 2000, 2010. This is where actually there were a lot of non-functional bug that actually came up, and it was also important for those companies to protect um, against attack. Okay, there were quite some attack that was happening against some companies like Sony. The PlayStation Network was attacked by hackers from North Korea. So those things actually um, were well formalized in the industry as non-functional testing, and those non-functional tests, they were part of a testing process, and they were given quite some flexibility in terms of security testing and so on. So over there, we combine automation testing and non-functional test together. Then there was the industrialization of the non-functional testing and the automation on the cloud platform like AWS and Azure. And now we are using AI to test. For example, we have self-healing testing in automation. So we have automation script that can use machine learning and AI to just correct itself. So this is something I'm experimenting with using AI to test. And there are a few principles on software testing, one of which is early testing saves times and money. As long as you can get those bugs early on during the software development life cycle, you're saving time and money before it goes to development or even in production. When you get a bug on production, fixing that bug will cost a lot of money because you have to take the environment down. You have to get developers, testers, go through the whole pipeline again. But when we get those bugs early on in the SDLC, it is cheaper and it is more cost effective in terms of time as well to fix them back than in the earlier stage of SDLC, software development lifecycle. We also have the concept of exhaustive testing is impossible. So we cannot test everything. Um, because when we say we are testing an application, it doesn't mean that there is no bug in it. It doesn't mean that we have tested all the possibilities. Let's say we have a function to add the sum of two numbers. Even there, you can't test everything because number line, where does the number line start and where does it end? It's minus infinity to infinity. So you can't cover all the test data. It will be only a segment of the test data that you will be able to cover. So exhaustive testing, covering all the test data, all the features and so on, it's impossible, right? So we have to apply the correct techniques to actually find the best way out. Okay, and testing doesn't show the absence of defect. So when you're doing testing, you are actually confirming the presence of a defect, but not confirming the absence of defect. So if you're testing and finding no bug, it doesn't mean that the software doesn't have any bug. It means that with the scope with which you are testing, there is no bug. Okay, there is no defect. It doesn't mean that the software as a whole doesn't have any defect. Testing carried out need to evolve. So we have the concept of having a test written, which is regression testing. These tests are executed after each, before release, after each development cycle. We have regression testing. We execute those tests over and over again. And then based on those tests, we can say we are ready to deploy to production or not. If those tests doesn't evolve, we'll be testing, finding bugs in the first few cycles, and then down the line, those tests won't get any bug. So the test as well need to evolve. Why the test need to evolve? Because the system is evolving. And why the system is evolving is because technology is evolving. The feature that the client needs on the software is evolving as well. They have new features, they have new wants on the, they have new needs as well on the software, and we are implementing those, and therefore the tests as well need to evolve. Software with no defect doesn't exist. Even Microsoft Windows, they are still finding bugs in those applications. They have been there for like 40 years, and there are still bugs in it. And lately, I was reading about one bug that was fixed in Windows 10. It was about the calculator bug. You can look for that on search engine on Google. You can look for that. So there was a bug when you have under root 2 it was giving you the wrong. So square root of 2 was giving you the wrong answer on the calculator application. So that bug was there since Windows 7. It went through Windows 8, Windows 8.1, and then it was fixed in Windows 10. And now on Windows 11, it's as well. It's not reproducible there. It's fixed there. So um, bugs are inherent part of software, and fixing those bugs depends on priority. That bug was in Windows 10, it was reported back then, but for Microsoft, it wasn't of high priority to fix because there were other bugs to fix, security vulnerabilities and so on. This is why if you're using Windows platform, when you restart your machine, sometimes you get Windows Update. What they're actually pushing is bug fixes towards your operating system. So it's updating it and fixing some bugs that you maybe your operating system might be experiencing. And what are the skills needed to be a good software tester in the industry? So the first one I would say would be curiosity, because as a software tester, we always need to ask questions to think outside the box and to get as much as information to allow us to think outside the box. So curiosity is one, asking question. For us as software tester, there is no stupid question. So we shouldn't have the fear of asking question. Then the analytical skill. So the ability to dig deeper to find the root cause. Then we have to communicate to the team in terms of the product and project risk, the teamwork, because given that we can't do exhaustive testing, we still have to do a certain um, testing, which is quite invasive, which is quite um, uh, uh, I would say effort intensive. So we need to work as a team, and we have to communicate within the team and have a good teamwork culture. Then we have the learning. So as a tester, we should be able to learn, to adapt to the new technology. We should always have this, if I don't know something, so I can learn about it and then I can perform the work better. So learning the product, learning the technology as the technology is evolving, learning again. So even in my career, I'm learning. Right now, I'm learning about Flutter programming. I'm learning also about security testing, and I'm experimenting with AI and learning about AI as well. So learning is a continuous process. In the IT world, it's like that, and even in testing. So testing is under IT, it's definitely like that. Learning is a continuous process. Then innovation, based on the knowledge that you've gathered, find ways on how you can innovate your day-to-day, innovate in your day-to-day job in terms of optimization, in terms of making um, jobs that you do, which take a lot of time, making it less effort intensive and so on. So those would be attributes that would make up a good software tester. And now let's get to the local context. So software testing in Mauritius. Software testing specialists as of now, if you go to platforms like My Job, um, you will see that there is a lot of specialists that are in demand on the market, right? So there's a lot of software test engineers out there. Companies are looking for those skill set on the market. The skill set of a software test specialist is more technical rather than being functional. So now we are expecting software test engineer. In the profile of the software test engineer, companies are looking for automation testing, some non-functional aspect of testing. So the skill set is evolving as well. So it's more technical rather than just being functional. Many multinational companies are looking to Mauritius as an outsourcing hub, and that means that there is a lot of opportunity for Mauritius as well to bring some project to Mauritius. Why? Because many large company actually started with outsourced QA services first in Mauritius. There's a lot of companies in Mauritius which are giants now that actually started back 10 years, 20 years back. So they started with outsourcing QA. They wanted to test the market with outsourcing QA. They performed well, and then they sent development, they sent DevOps, they sent other projects to Mauritius. So when we have competent QA on the market, it means that we can open the opportunities for other companies as well to settle in the country. And other companies being in the country means we are as well um, growing and enforcing the ICT pillar, which is the economy, which is part of the economy of the country. And the software testing market in the region is growing competitive. Yes, because right now Mauritius is competing on two aspects. So it's the time zone. So we are in GMT +4. We can provide like 24-hour services to customers from Europe, from UK, from US as well, um, to cover their support. Let's say for those needs for industries that are requiring 24-hour service. So Mauritius is in the good time zone, and also we are bilingual, English and French. But alone on these two aspects, we are not able to compete with giants. For example, next door we have Madagascar, we have India, we have South Africa, which are also evolving in the same market. And over here, for us to be competitive as well in software testing, competence will be the keyword. So growing competencies in terms of non-functional testing, functional testing, having certification, being technology oriented, and so on. This will make the difference, and this is what will actually enforce again the ICT pillar in Mauritius. That's the local view on how testing is in Mauritius. Now, what about us? So, us is MSTQB, Mauritius Software Testing Mauritian Software Testing Qualification Board. So we are a non-profit organization that represent ICTQB locally. Our mission is to create awareness about software quality industry. So participating in these conferences, in these speeches, is part of our job. Given that we are a non-profit organization, we do it free of charge. We are just volunteers on the board. So our aim behind is to promote the best practice on software testing and related competencies to keep Mauritius competitive in the region. We are opening quite some certification program to the Mauritian population. For example, ICTQB certification that were initially closed are now open. We have automation testers, we have performance testers, security testers certification, which is open now to the Mauritian population. We have also open certification like A4Q, Alliance for Qualification, Selenium testing, TMMI. We are trying to get that TMMI certification as well in Mauritius. We are looking forward to work with academic institutions to upgrade the syllabus. We have to make sure that our education or academia and the IT industry are aligned. So we are trying to bridge the gap and work with those institutions to have some aspect of software testing in the syllabus as well. Because I'm involved with quite some interviews, and we find this gap between the academia and the expectation that we have as IT professional in the industry. We find that the gap is growing, and our contribution is to make sure that these gap, we are trying to bridge it to the lowest level possible. And also, as MSTQB, we are promoting Mauritius as an in international events to bring opportunity to the countries, to the nearby countries, and to the region as a whole. So we as MSTQB, we are trying to promote as well Mauritius based on the competencies that we have in the country. So if you would like to learn more about our activities, our mission, and so on, so you can connect to mstqb.mu. And then if ever you have any question anyway, you can connect with me on LinkedIn as well, and send me your question. So this brings me to the end of my talk. So if you have any question, I would be glad to clarify those.
Thank you very much, Mr. Lovelesh Beeharry, for this very interesting lecture. I'm sure it has cleared up many doubts that many of us had in terms of software testing. I've taken note of your comment of the disparity between academia and the requirements of the industry. And I can assure you that we will do our utmost to try to bridge this gap. We will now pause the recording and we'll open the floor up for questions. So dear participants, I will ask you to type your questions in the chat, and our resource person will try to attempt to provide some answers.